It is well known that the limit of sine x over x when x tends to 0, it is equals to 1. Now we are going to use this result to generate some interesting question on limit. One of the questions that we can think of is using the fact that the limit of 1 plus n to the power of 1 over n when n go to 0 equals to e. With these two results, we are going to find the limit of sine x over x to the power of 1 over x squared when x tends to 0. Notice that when x tends to 0, sine x over x is 1. Similarly to this one, when n go to 0, 1 plus n tends to 1. When x go to 0, 1 over x squared tends to infinity. And for this, it's either tend to infinity or negative infinity. Then we may predict that if the limit exists, it must something to do with e. And let's try. I'm going to provide you two different methods, and you may choose which method you like. The first method, write sine x over x as x plus sine x. After this will be equal to 1 plus sine x minus x over x to the power of 1 over x squared. In my previous video, we have the following result. That is, limit of x minus sine x over x cubed. When x tends to 0, it is equal to 1 over 6. And with this, we'll see that when x tends to 0, sine x minus x over x will tend to 0. And this can be seen using a simple trick, that is sine x minus x over x when x tends to 0 will equal to the limit of x minus sine x over x cubed. This is what we know, and negative x squared. The limit of the first term and the limit of the second term both exist. So it will be equal to 1 over 6 times 0, and therefore this is equals to 0. So we confirm that when x tends to 0, this whole thing will go to 0. And now we have the form 1 plus n when n go to 0. We'll do something to the power. According to this limit, it must be 1 plus n to the power of 1 over n. So 1 plus n, 1 over n. 1 over n will be equal to x over sine x minus x. And note that these two are not the same, so we can change a little bit and change as sine x minus x over x power 3. Then x go to 0. Note that a to the power of mn equals to am power n. So this is amn, it will be equal to am power n. Now note that this limit exists and is equal to e. And the limits here also exist. It will be equal to negative 1 over 6. And therefore the answer is equals to e to the power of negative 1 over 6. And we are done. This is the first way to obtain the answer. Now we should go to the second method that may not be so rigorous. For the second method, we use a Maclaurin series for sine x, and we will have this is x minus x cubed over 3 factorial plus x5 over 5 factorial, and so on and so forth, over x to the power of 1 over x squared. X go to 0. We'll get 1 minus x squared over 6. And we ignore the rest because they are too small and not significant. This is a step that I mentioned just now that is not so rigorous because we just simply ignore something that we think they are not so significant. I'll give you an example later on to show that something not significant may be important when there are so many of them. Okay, nevertheless, let us continue. So from this step, 1 plus negative x squared over 6, this is n. So we need to write 1 over n. 1 over n will be equal to negative 6 over x squared. Okay, and notice that what we have here is this is x squared. We have it already. Negative we don't have. 6 we do not have. So this is what we have. Again, a m times n is equal to a to the power of m to the power of n. And we already know that this limit is equal to e. And this is a fixed number, negative 1 over 6. So the answer is e to the power of negative 1 over 6. But we have to note that for this step, it is not so rigorous. I'll give you an example that something that insignificant may be important. Example, the limit of 1 over n squared plus 2 over n squared, 3 over n squared, and so on until n over n squared, where n tends to infinity. Call these limits as j. The first method of doing this is because each of the limit is equal to 0 for all k in between 1 and n. Okay, and therefore j will be the summation of all 0 and therefore equals to 0. Do you agree with this argument? Let's look at the second argument. It is a limit of 1 plus 2 plus 3 and so on until n over n squared. Okay, we combine them first. Then this is equal to n plus 1 over 2 over n squared. So this will be n squared means it's n times n. 1n cancel, 1n cancel. This is n plus 1 over n over 2. When n is big enough, this is equal to half. How do we know that which answer is correct? We can try for some fixed n. Example, n equals to 10, n equals to 100, n equals to 1,000, 10,000, and so on and so forth. You see that the answer will be closer and closer to half. Therefore, we conclude that this is not correct. The answer should be equal to half. So, can we use the second method that we have just now to say that sine x is approximate to x minus x cubed over 3 factorial, and the rest of the term is not so important? Can you use that argument? If you can use that argument there, why you can't use a similar argument here? Please let me know your comment. This is what we have proved today using 2 different methods. The second method is not so rigorous, but the advantage is it is quite fast to get what will be the answer. And with this, we can use the first method to verify the answer using more rigorous way. And now it is the time for you to check on this limit. 2 to the power of x minus 2 to the power of sine x over x to the power of n when x tends to 0. Okay. Given that the limit of this is equal to a, where it is not equal to 0, then in this case, what is the value of n and what is this limit? You may try it, and I will leave the answer in the description. This is the end of the lesson. See you again. Bye-bye.